In this video, let us solve more problems based on trigonometric ratios. So here is a question. In a triangle ABC, right angled at A, if AB equals 5, AC equals 12 and BC equals 13, find sine B, cos C and tan B. Or this is nothing but this is sine B, cosine C and tangent of B. So these are the short forms. These are the abbreviated forms of the trigonometric functions, sine, cosine and tangent. So as far as this problem is concerned, let us first draw the required diagram. So now we've got a triangle ABC, and more importantly it is right angled at A. So let us first draw a right angle, say a random one, and let's name it A. So now just join the other two ends of this triangle. So we have ABC here. So now in this triangle ABC, which is right angled at A, if AB equals 5, here is AB which is equal to 5 and AC equals 12, so AC is 12 and BC is 13. So now given all the sides of this right angle triangle, we need to find sine B, cosine C and tangent of B. So now let us start off with sine B. This is angle B. So let's find sine B. But before that, let us write whatever is sine theta. What is sine theta? Sine theta is defined as a ratio of opposite and hypotenuse. So sine theta is opposite by hypotenuse, but in this case we need sine of B. So sine B, now which is the side that is opposite to B? It is AC, which is 12. So it is AC divided by hypotenuse is BC. Now no matter which is the angle that is being referred to as far as trigonometry is concerned, the hypotenuse is not going to change. But if you can notice, the opposite and adjacent are going to change depending on what angle are we talking about. So in this case, since it is B, the opposite is AC and the adjacent is AB because it is the opposite side to B and the adjacent side to the angle B. So let's get back to sine B now. So sine B is AC by BC, which is equal to AC is equal to 12 and BC equals 13. So it is 12 by 13. And then we've got, so this is sine B. Sine B equals 12 by 13. The next one that we need to find is cos C. So what is cos C? Before we go to cos C, let us see whatever is cosine of theta. So let me make this cos theta. Cosine of theta is adjacent by hypotenuse. So in this case, we need cosine of C. So the angle C is here. So it is cos C. So the side that is adjacent to C is AC. Here it is. So adjacent is replaced by AC and hypotenuse is the same in a given triangle. So it is going to be BC. So AC equals 12 and BC equals 13. So cos C is the same as sine B. So sine B is 12 by 13 and cos C is also 12 by 13. Now let us find the third one, that is a tangent of B. So before we go to the tangent of B, let us write down whatever is tan theta. Tan theta is nothing but opposite by adjacent. So in this case we need tangent of B, so we write tan B here. We already know what is the opposite to B. The opposite to B is AC and the adjacent to B is AB. So tangent of B is AC by AB, which is nothing but AC is 12 and AB is 5. So here we have sine B equals 12 by 13, cos C equals 12 by 13, tan B equals 12 by 5. This ends this problem, which is a very, very basic and a very simple problem. Let us go on to the next problem now. So here we have another question which reads like this. In a triangle ABC, right angled at B, if AB equals 12 and BC equals 5, find sine A and tan A and cos C and cot T, or sine A and tangent of A and cosine of C and cotangent of C. So now, first of all, let's get the diagram for this problem, right? So it's given that in a triangle ABC, right angled at B. So again, let us draw the diagram. Say, let us draw the right angle, and the right angle is at B. Just join the other two sides, then it becomes a right angle triangle. So we have ABC. So since AB is 12, let's take this as AB and BC is 5. So AB is 12 and BC is 5. Now we need to find sine A and tan A and cos C and cot C. So now we know that sine of theta is nothing but opposite by hypotenuse, and tangent is opposite by adjacent, and cosine is again adjacent by hypotenuse, and so on. But then, if you notice very carefully in this figure, we've got the values of AB and BC, but then we don't have the value of AC, which is the hypotenuse in this case. So without having the value of the hypotenuse, we cannot find the value of sine of any angle, nor can we find out the value of cosine of any angle. So the first step in this problem, I think you have already guessed it, right? We need to find the hypotenuse. And you know that as far as the right angle triangle is concerned, the only theorem that we have to use is the Pythagoras Theorem. So we need to use the Pythagoras Theorem to find the length of the hypotenuse. It just states that the square of the hypotenuse equals to the sum of the square of the other two sides. In this case, it is AC square equals AB square plus BC square. So we need to find AC. So AC square equals AB square is 12 square plus BC square is 5 square. So AC square equals 12 square is 144 plus 5 square is 25. So AC will be equal to root of 169. 144 plus 25 is 169, and the square root of 169 is 13. So the value of AC is 13. So the first step as far as this problem is concerned is to find the length of the side whose length was not given. So that's what you have to do first, because only with that can you find out the value of sine or cosine. But remember, the tangent and the cotangent do not need the value of the hypotenuse, because the tangent of A is nothing but opposite by adjacent, and cotangent of C is nothing but adjacent by opposite. So we need this value only for sine and cos. So now let's go ahead and find sine A, tan A, cos C and cotangent of C. So sine A equals opposite by hypotenuse. So A is here. So the side opposite to A is BC. We have BC divided by the hypotenuse, which is AC. So the value of BC is 5 and the value of AC is 13. So hence we found the value of sine A, which is 5 by 13. Now let's find the value of tan A, or the tangent of A, which is equal to opposite by adjacent. So which is the opposite side to angle A? It is CB, which is 5 centimeters or 5 units. It may be 5 centimeters, 5 meters, 5 kilometers, anything. But we just need the value of it. So tan A equals opposite by adjacent. The opposite to A is BC. So I write BC here divided by adjacent, which is the side that is adjacent to A. It is AB. So now just replace BC and AB with their values. BC is 5 and AB is 12. So tan A's value is also found, which is equal to 5 by 12. Next we need to find cos C. Cos C equals, now here we need to solve this problem with respect to the angle C. Cos C is nothing but adjacent by hypotenuse. So at the side that is adjacent to angle C is BC. So therefore let me write BC here, and by hypotenuse is nothing but the same as everything, because one triangle just contains one hypotenuse, which is AC in this case. So the value of BC is 5 and the value of AC is 13. So therefore we have the value of cosine of C as 5 by 13. And the final value that we have to find is cotangent of C, or cot of C, which is cot C equals to adjacent by opposite. Now which is the side that is adjacent to C? It is again BC, and the side that is opposite to angle C is AB. So now replacing the values of BC and AB by 5 and 12 respectively, because BC measures 5 and AB measures 12. So therefore we found the final and the last value of the given question, which is cot C, or cotangent of C, equals to 5 by 12. So this ends this problem. This problem was no different from the previous problem that we solved, except for the fact that we had to find one side using a theorem that is very well known. We even studied this in the previous academic year. So there is nothing new as far as this video is concerned. Pretty simple video this. So I hope you don't find any problems solving these questions.